So in today's video, we are going to be learning about the outliers and how we can extract outliers from our dataset by using the interquartile range method, also known as the IQR method, or also sometimes known as the box plots method. So that being said, the first step in learning is for us to know what an outlier is, and in simple terms, an outlier is actually a single value or more than a single value that is extremely large or extremely low in value when compared to other variables in our dataset. Let's take an example. And here is our first example. We have the data set of 199, 100, 101, 103, 109, 110, and 201. And it is very obvious that the outlier in this data set of ours is going to be 1, and that is because 1 is extremely small when compared to the other variables present in this data set. We have 99, we have 100, we have 101, we have 201, but 1 is actually the smallest. So that simply implies that 1 is the outlier in this data set. Let's take another example. In the second example of ours, we have 2, we have 55, we have 60, we have 45, we have 65, and we have 60. And as we can see, the smallest variable in this case of ours is actually 2. As we can see from this example, 2 is the least smallest variable present in this data set. So that means that 2 is the outlier when compared to other variables in this data set. So let's repeat it once again. An outlier is just that single variable or those list of variables that is either extremely large or extremely small when compared to other variables in our data set. So for our third example, we have 2, we have 5, we have 4, we have 65, and we have 6. And taking a closer look at this example, we can see that most of the variables are actually of little value. We have 2, 5, 4, 4, 6, and 65 is just this value that is extremely large compared to other variables. So definitely 65 is actually the outlier present in this dataset of ours. From example 1, 2 down to 3, we can see that it is easy for us to spot our outlier by just looking directly into our dataset and look for the smallest or the largest variable, and that is the outlier. In real life situations, most times our data set does not come in an easy format like this, where we can just stare into the data set and be able to see the outlier directly. Sometimes the data sets can be a bit funny, and you might not be able to just tell if a value is an outlier or not. You might be even be thinking that a value is an outlier, and after using some method you realize that, oh, you're wrong, that the outlier is another number. Let's take another example to explain this concept. So take a look at this example of ours. We have 61, 10, 32, 19, 22, 29, 36, 14, 49, and 3, and we're supposed to get the outlier. Taking a straight look at this dataset, we can see that the smallest value is 3, the highest value is 61, and if I'm to use the idea of the lowest value or the highest value being the outlier, then definitely the variable 3 and the variable 61 is definitely going to be an outlier in this data set of ours. But I am going to tell you that that is wrong, as we would see when I use the methods to extract out the outliers. So that is why in statistics, whenever you are given your data set, the first few steps you have to do after arranging and sorting your data before you try to visualize your data is to actually extract out outliers from your data set, because outliers can have a big effect on the mean of a data set. So we try to remove outliers from our data set. And that being said, there are several methods that we can use to extract outliers from our data set. In fact, we can use softwares to extract outliers from our data set. We can use Python, we can use spss, we can use stable, we can use any statistical software available to get to extract out outliers from our data sets. We can also use the z-score method to extract outliers from our data set. There are other tests in statistics that we can also use to extract outliers from our data set. We are talking about tests like the generalized ESD, we are talking about the groups test, we are talking about the Dixon's Q test, we are talking about the modified Thomson-Tau test, we are talking about the Pearson's criterion test, and the last method but not the least method is the usage of the interquartile range, also known as the IQR method, or sometimes called the box plot method rather, to extract out the outliers from our dataset. And that is what we are going to be learning today. So that being said, let's move into it properly. Just like the name sounds, the usage of the IQR or the interquartile range to extract outliers from our dataset is just us using the interquartile range to extract out outliers from our dataset. So when we try to use the interquartile range to extract outliers from our dataset, it kind of stem out from the usage of box plots to actually extract outliers, although they are a bit different, but they are almost the same thing. I'm going to be linking a video in the top right corner on what a box plot is and how we can construct a box plot and all, so you can just go check that out. And when it comes to using the interquartile range to extract out outliers from our dataset, we basically need three details. That is that the first quartile, the third quartile, and the interquartile range itself. In fact, some tutors will tell you that you need the 5 summary number that you need in constructing a box plot to work on your interquartile range method. It doesn't matter, but you just basically need just 3 values: the first quartile, the third quartile, and the interquartile range. And once you have these 3 values, you can apply them to your data set and create what we call a fence or a boundary that can help you know if a value is an outlier or not. So the basic principle or the basic concept behind the usage of IQR to extract outlier is that you are going to be having 2 sets of values. These 2 sets of values are going to be serving as a boundary, or we can say they are going to be serving as this fence that helps you to shield values of and let you say, oh, this guy is an outlier, this guy is an outlier. Now these 2 values are basically the lower boundary and the upper boundary, so you can decide to call them anything you want to call them. We can say the lower boundary, we can say the upper boundary. And when you use the interquartile range, the lower boundary, let me just call that here the lower boundary, is definitely having the formula that says Q1 minus 1.5 times IQR. So this is the lower boundary of the fence we are creating to extract out outliers. And the upper boundary, which is right here, it's going to be Q3 plus 1.5 times IQR. As you can see, we only made use of just 3 variables: the first quartile, the third quartile, and the IQR. And we need to know that the IQR rather, which is IQR, is actually the difference between the third quartile Q3 and the first quartile. Very important, we need to keep that in mind. So once we have the lower boundary and we have the upper boundary, then we can be able to extract out the outliers present in that data set. And how do we do that? Now, any value lesser than the lower boundary is an outlier, and any value greater than the upper boundary is also seen as an outlier. Once we can keep that in mind, we can be able to extract out any outlier present in our data set. So let's quickly rush over it once again. So using the IQR method, you are going to be using the first quartile, the interquartile range, and the third quartile to create a boundary, this fence of values. And the lower boundary is a Q1 minus 1.5 times IQR, and the upper boundary is a Q3 plus 1.5 times IQR. Any value that is lesser than the lower boundary is seen as an outlier, and any value that is greater than the upper boundary is also seen as an outlier. So that means that the non-outliers value are going to be values that are between the lower boundary and the upper boundary. So that being said, I would be using the IQR method that I just explained right now to solve example 4, and we use that to extract out the outlier present in the data set. So let's get into the worksheet and solve this question. We are even in the worksheet, so let's just erase this off and get things done. So let's just take this, let's keep this somewhere here. So we want to use the interquartile range to extract out the outliers present in this example 4 of ours. So we have 61, 10, 32, 19, 22, 29, 36, 14, 49, and 3. We can see that this data set of ours is actually a data set in the raw format, in the ungrouped manner. So that means that we are going to be getting the first quartile and the third quartile of an ungrouped data. We've actually done that in previous video, and I'm also going to be linking a video about that in the top right corner, so you can just go check that out, but I'll still try to go over it right here. So the first step is for us to get the first quartile, and the formula for the first quartile can come in two variations. We can have our Q1 to be equals to, we have 1 over 4 times n, and we use this variation when we have when we have even number of variables or even number of data sets, and we have our Q1 is equals to 1 over 4 into brackets n plus 1, and we use this variation when we have a odd number of data sets. We also have for the third quartile, which is going to be Q3 is going to be equals to 3 over 4 times n. We use this when we have even number of variations, and we have a Q3 is equals to 3 over 4 into brackets n plus 1. So we use this variation when we have odd number of data sets or odd number of variables in our data set. So that being said, we have to count the number of variables we have in our data set. That is, we have to get the size of the data, and that is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we definitely have 10 of them. So that means that we are going to be using the Q1 and the Q3 formula for the even number of variables variation. So that being said, the first step in getting the quartiles is to actually arrange our data sets in ascending order, and by ascending order it means we should arrange the data from the lowest down to the highest. So let's quickly go through that and arrange our data sets in ascending order. So this is our data sets in ascending order from the lowest down to the highest. So the first step is for us to get the first quartile. So let's get the first quartile. Q1 is actually going to be equals to 1 over 4 times n, and that is going to be equals to 10 divided by 4. And when we do the math, 10 divided by 4 is actually going to give us 2.5. So that means our first quartile is located in the 2.5th position. Sometimes we can decide to approximate this to 3, but let's just keep it in this manner. So let's come to the data set and locate the 2.5th position data set, and let's come here. So this is the first position, this is the second position, and then 2.5 is going to fall somewhere right here. So that means we can say that our first quartile Q1 is actually equals to 14. We keep that in mind. So let's get the third quartile. So our Q3 is going to be equals to 3 over 4 times 10. So that's going to be equals to 30 divided by 4. And when we do the math with our calculator, 30 divided by 4 is going to give us 7.5. So let's locate the 7.5th position data. So this is the first, this is the second, this is the third, this is the fourth, this is the fifth, this is the sixth, this is the seventh. So the 7.5 is going to be right. Excuse me, is going to be right here. This value right here, which is 36. So that means our third quartile is going to be equals to 36. So Q3 is actually going to be equals to 36. So that being said, we've gotten the first quartile, we've gotten the third quartile. Now the next step is for us to get the interquartile range, and the interquartile range is very simple to work with. So the IQR is actually going to be equals to the third quartile minus the first quartile, and that's going to be equals to 36 minus 14. So 36 minus 14, that actually gives us 22. So that means that the value of our interquartile range is actually equals to 22. So having these details, we can now slot the value of the Q1, which is 14, the Q3, which is 36, and the IQR, which is 22, into the lower boundary and the upper boundary formula to get our fens or the boundary values. So let's take this towards the left. So we can just shift this a bit, and then we have that the lower boundary, that is LB, that's going to be Q1 minus 1.5 times IQR. So our Q1 right here is actually equals to 14 minus, so we have 1.5, and the IQR right here is actually equals to 22. So we have a 14 minus, so 1.5 times 22, that's 1.5 times 22, and that gives us 33. So 14 minus 33, and that gives us minus 19. So the lower boundary of our fence is actually equals to minus 19. So let's get for the upper boundary. So for the upper boundary, so we have UB, we have the Q3 to be equals to 36 plus 1.5 times 22. Okay, so we have this to be 36 plus, so 1.5 times 22, that gives us 33. So 36 plus 33, and that gives us 69. So the upper boundary is equals to 69 and the lower boundary is equals to minus 19. So as we can see, no value is actually lesser than minus 19, because the least value in this data set of ours is actually equals to 3. Since the lowest value 3 is not lesser than minus 19, so that simply implies that from the minimum value perspective, there are no outliers. Taking a look at the upper boundary, we can see that the maximum value in our data set is actually 61, and 61 is lesser than 69, so that means that no value in this data set of ours is actually greater than the upper boundary, and no value is also lesser than the lower boundary, which simply implies that this data set of ours does not include any outlier. So that means this data set does not have any outlier. If you learned something new from this video and you enjoyed this video, I would really appreciate if you can give this video like a thumbs up and turn on your notifications to get notified when I release new video, which I do at least 2 times in a week. Thanks for making it to the end of this video, and we see in the next one. Bye for now.